We have discussed about the contaminants which are affecting the insulator performance in the field, either in substations or transmission system. These contaminants over a period of time could create a flashover and the tripping of the lines. So, proper cleaning mechanism is to be adopted in the transmission system or in the substation. So, various methods are being employed by the utility personnel in the field. There are prescribed methods which are being followed. IEEE standard the 957 is one of the method which gives the guidelines for the cleaning of insulators in substations and also in the transmission system. Here this standard or the method guidelines which are given in this standard mentions about the importance of the methods to be followed and various procedures to be adopted by the utility personnel. So, we know that various types of insulators in the substation are being to be maintained. It could be the post insulators, it could be the insulators housing which are employing the arrestor elements, that is the arrestor surge arresters. Here again the porcelain or ceramic arresters, recently polymer based arresters. So, the methods which are being used have to be properly planned. There are bushings or the insulating hollow insulators which are being used for the current transformers CTs, the potential transformers the PTs and various substation equipment where the bushings are used to mount the high voltage equipment. These bushings should also be regularly maintained, cleaned so that the dust or the accumulation contaminants never accumulate on that and the performance of this insulation comes down. So, various methods are being suggested in this standard. We will focus on the importance of the methods, the procedures which are to be employed both during a live line or hotline washing, that is during the energized conditions and during the de-energized conditions when the power supply is switched off for the maintenance aspects. So, the methods differ to an extent for energized and de-energized. So, proper care has to be taken in particular when the maintenance is being carried out during the energized condition, that is a hotline or a live line maintenance period. So, the potential levels have to be looked into, the nozzle jets which are being used, proper insulation of the personnel and the safety aspects have to be considered when the maintenance of or the cleaning of insulators is being done. So, we will look into the important scope or the purpose of this guidelines have been made. So, this standard 957 clearly prescribes the procedures basically used for the cleaning of contaminated electrical insulators for all types, ceramic, porcelain, glass and also the recent polymer insulators, and for the equipment which are being used, that is the bushings, the hollow post insulators and so on. So, various equipment and the techniques to be followed are mainly under the scope of this standard. It also describes the number of approaches to be adopted for cleaning of insulator in the power system network. The main purpose of this guide is to present information on the equipment which is needed and the methods this can be used while cleaning the contaminated insulators is of prime importance. The methods or equipment or both presented are mainly not intended to prescribe specific procedures, but here it is seen that to present the successful experience of many individuals in the utilities or in the power working in the power networks systems who have safely done the job of cleaning the contaminated or polluted insulators. So, with the inputs this guidelines are being made and is mainly intended to serve as a reference source for an utility company or the personnel who are working in the substations or in industry where the high voltage equipment or the insulators systems are being used. And the cleaning procedures which are to be followed are being prescribed, and modifying or formulating of the cleaning process could also be carried out appropriately. Insulators to be cleaned are mainly of transmission, distribution, substation, again post insulators, hollow type of both the ceramic, polymer materials. The insulators should be washed so that the water sheds which are cleaned will maintain adequate insulation. This is of importance. So, once the pollutants or contaminants are cleared, the insulation level of the equipment or the insulation part will be improved. So, one of the main concerns of washing from different portions, again in case of the insulator strings in the field, we discussed various type of configuration. It could be a suspension, it could be a tension, it could be a V suspension combination in the field for EHV and UHV transmission system. So, during the cleaning of particularly V type of string, the contaminants or the pollutants could be carried to the other string, other arm of the string. So, here proper mechanism has to be followed where the spray should be in such a way the cleaning of the insulators of one side should not contaminate the other insulation of the other side. So, when in case also about the overspray, one of the main concerns is because sometimes the washing could create the put of overspraying. So, when overspraying presents a problem, washing from different positions could also help. So, two different directions have to be followed for cleaning in such cases. So, transmission line or distribution insulators of ceramic, porcelain, glass which are connected with the galvanized hardware are most common practices or most common insulators which are to be cleaned regularly. So, any cleaning technique which is employed for the cleaning purpose, the main intention should not be to damage or deteriorate the surface of the insulation system during the cleaning process. This has to be kept in mind by the utility personnel who do the cleaning technique. So, cleaning is a better thing to be carried out, but again damaging the shed or the petticoat could also cause an issue. So, proper mechanism or a technique is to be employed. So, ceramic insulators can be cleaned in number of ways, and they can either be as mentioned during the energized, that is a hotline maintenance, or during the switched off conditions, that is a de-energized condition. The most methods, common methods which are being used are the following for the ceramic or glass type of insulators in the transmission system. So, various methods are being suggested and are being practiced by the utility personnel. High pressure water, here the water pressure could be 2750 kilopascals to 7000 kilopascals, or the pressure could be of 400 psi to 1000 psi. The medium pressure water jets which are being used could be 2100 kilopascals to 2750. This is 300 psi to 400 psi. The psi is pressure per square inch, that is kilopascals kPa. So, low pressure water, again here flood washing is type of arrangement is made with 1400 kilopascals, that is somewhere around 200 psi. So, low pressure water fixed spray nozzle, these are done for a particular location where insulator are fixed. So, in such cases for cleaning spray type of nozzles are fixed and it will be used regularly for the cleaning. The jets which are connected, the nozzle jets are fixed so that a regular cleaning could be done. So, compressed air cleaning, here again depending upon the surface conditions, we will be discussing about this in further. The corn cob and carbon dioxide pellets are also being used to clean the surface where the surface contaminants which are hardened on the surface have to be cleaned. In such cases corn cob or carbon dioxide pellets are used for with the help of a compressed air cleaning. Some cases hot wiping, that is using a live line tool, the insulators are with a certain temperature the wiping is done, and some of the cases it is hand cleaning with the cloth or with a smooth cloth. So, these are some of the common methods which are being used for the ceramic or glass insulators by the utility personnel. In case of polymer which are of recent origin, no methods are being presently available. So, there are methods which are being followed by the utilities in cleaning, but here the manufacturers to be consulted priorly, as these polymer insulators are of organic where using a higher pressure with could damage the sheds or the rubber surface condition, rubber sheds of the insulator surface. So, manufacturers have to be consulted prior taking up the cleaning on the respective products, and applicability of the cleaning methods have to be discussed. So, there are some methods which are being followed. We will be discussing both for ceramic and for polymer insulators which are in substation, which are in transmission and distribution systems. So, this table shows the water pressure washing particularly for polymer insulators. You can see for polymer insulators there are materials which are like direct molded units of composition of silicon, EPDM, alloy, PPDM as epoxy type of material, and polymer ceramic. These are various molded units which are being used for the bushings, which are used for the high voltage equipments. This example for silicon which are used to low to high pressure, here for cleaning purpose for silicon they use a low to high pressure water washing, which could be somewhere 1400 kilopascals to 7000 kilopascals depending upon the contaminants. The second for the EPDM could be high pressure washing in the range of 2750 to 7000 kilopascals. The alloys and the EPDM materials, wherever it is being used, they use the high pressure water washing again in the range of 2750 to 7000 kilopascal. Similarly for epoxy, the similar pressure of the water washing is being done for the epoxy molded insulators wherever they are being used. In case of polymer ceramic type, medium to high pressure water washing is normally employed somewhere around 2100 kilopascal to 7000 kilopascal. So, for individual watershed bonded to a polymer sheath or to each other, here again different methods are being followed, like for a silicon rubber low to high pressure water washing with 1400 kilopascals to 7000 is being employed. For EPDM or EPR high pressure water washing with again like the previous methods 7050 kilopascals to 2750 to 7000 kilopascals is being used. Similarly for alloy EPDMs high pressure water washing is being normally followed. So, what happens in case of individual water weather sheds with an unbounded interface? Previously was the bonded to a polymer sheath. This with an unbounded interface, here for all the compounds, that is silicon, EPDM and alloys, Normally the utilities use 1400 kilopascals at the pump with 6 mm nozzle and no closer than 4.6 meters. So, this method is being employed. So, for type 1 and 2 you can see for direct molded units and for individual weather shed bonded to a polymer sheath, the water stream may be directed at any angle to the insulator axis. So, in case of third, that is a individual weather shed with an unbounded interface, it requires the water stream to be directed on the upper or a angular surface of the weather shed, which is at an angle greater than 90 to the insulator axis. So, these are being given as the guidelines for washing the polymer insulators in the substations or in the transmission systems. So, what is the washing frequency or the cleaning frequency to be adopted? Here again the polymer insulators that require washing or cleaning do not require as often as the porcelain or a glass insulators, because most of the time glass or porcelain insulators have been seen to accumulate more pollutants in comparison to the polymer type. So, they may be washed in case caution is used during washing procedure along the manufacturer's approval. So, polymer insulators or strings may be cleaned by methods other than water washing also. So, there are two methods for the cleaning as mentioned earlier. One is a de-energized cleaning. This is the supply will be switched off for the maintenance aspect, and other is the energized cleaning. During the energized conditions using the live line or hotline tools, the maintenance will be done or the cleaning of the insulators is done. So, in case of de-energized cleaning, so the insulators can be the supply to the insulators is normally switched off for cleaning. Here again they may be hand washed with cloth or wiping with the cloths with a mild detergent water. Again this depends what type of contaminants on the insulator are spread. We will further discuss about how the methods are to be used, what type of arrangement or what type of techniques are to be followed for various type of contaminants. Here this should be followed by a low pressure after the cleaning or wiping with the cloths, low flood rinse with clean water to remove any residue which is present on the surface. So, various solvents or harsh abrasives are normally not recommended. So, these solvents, some of the solvents or harsh abrasives may damage the surface conditions. So, that is one of the reason where these are not recommended for the cleaning. Wetting agents or additives can be used for improving the washing action of the cleaning. So, here choosing of these wetting agents is of also equal importance. The solvents may be used provided cleaning residue is removed by the final water rinse. That is, once the cleaning is done by the rags or the wiping of the cloths followed by a mild detergent water, this had to be cleaned up. So, these things are normally undertaken with the approval of the manufacturers, in particular to the polymer insulators. So, that was about the de-energized condition. Now, we discuss about the energized cleaning, that is during the power supply which is on conditions. So, where hotline tools are being employed or a hotline maintenance what we call is being used for the cleaning of insulators. Here again compressed, that is compressed air and dry abrasive cleaning is normally used. This procedure involves use of compressed air and dry abrasive cleaning media. So, again abrasive cleaning compounds often consist of the ground corn cob mixed with ground walnut or pecan shells. So, these are generally used for cleaning or removing the dirt on the insulator surface. So, actual cleaning process is similar to sand blasting. In that, a pressurized air stream is generally used to bombard the insulator surface with abrasive media, so that the collected pollutants on the surface move away from the insulator surface. So, this pressure which is being used after cleaning, the contaminants and the abrasive residue which remains on the surface are to be blown off with dry, clean or a compressed air arrangement. So, these are all done during the energized condition with the supply on. So, with proper cleaning media and procedures, virtually any contaminant can be safely removed from the insulator surface. So, the abrasive cleaning techniques are generally not recommended for silicon rubber, as earlier mentioned, as these abrasive or harsh methods could damage the surface or the rubber sheds of a polymer or a silicon rubber insulators, and they can temporarily or permanently destroy the surface hydrophobicity conditions. So, hence the methods which are very harsh or high pressure techniques are not to be followed for the ceramic for the porcelain polymer insulators. Some of the energized conditions, so these give some methods which are being followed by the hand pressure jets which are being cleaned during the live line conditions. The distance of the personal, the equipment which is being used is also very important, and how the cleaning procedure has to be done with the help of insulating trolley, where a personal uses an insulating mechanism for cleaning the insulators. This is again one of the similar method for cleaning the substation insulators with insulated equipment. These are all some of the methods which are used for the live line maintenance, that is during the power supply energized conditions, to clean the insulators at substations or transmission or distribution networks. So, these are give you an idea of proper methods to be followed with necessary safety measures and using the safety equipments for the cleaning. So, what happens in case about the greased insulators? So, some of the insulators over a period of time, the contaminants could be of oily in nature or a grease which could be hard on the insulator surface. So, the water jets may not be able to clean the insulators, or normal cleaning with the cloth may not be sufficient. So, in such cases the methods to be followed, either it could be in energized or in de-energized conditions. It is possible to de-energize in some cases and also to follow the energized conditions. Here insulators may be cleaned either by hand, simply by wiping on the contaminated grease with using the cloth, or the grease coating which is very hard and caked on the insulator surface must be necessary to chip or scrap the coating, or sometimes use a high pressure air blast that delivers ground up corn cobs, walnut or a pecan shells against the insulator surface. So, it has to be in case of porcelain insulators. So, these are the things which have to be employed for the cleaning of insulators. The air blast should not be directed against one spot for too long, as the ground material may damage the porcelain glaze. So, the residual dust can be blown off with clean air. If insulators must be cleaned in an energized state, air blast corn cob method should be considered. The cleaning equipment with properly insulated vands is available commercially, where it is being used for cleaning the greased insulators. There can be used of some solvents which can also be used to soften the grease before removal by hand or by high pressure water spray. So, several techniques or methods are being used to clean the greased insulators in the energized or de-energized condition. So, proper care has to be taken. So, while removing the coating, greased coating, the damage, surface damage to the insulator should not be done. And while applying the fresh silicon grease over the contaminated silicon grease is also not recommended, as the contaminated grease which is earlier must be removed prior to coating a new layer. This is an important point to be considered in particular to the coatings which are of grease in nature. So, simple hand wiping with disposable paper towels, cloths or porous hand pads is all that is required. For cleaning silicon grease insulators on energized lines, use of demineralized water spray, which is a relatively low pressure 850 kilopascals, that is 125 psi, and a high capacity of 3.2 liters per second or 50 gallons per minute is normally recommended. Removal of silicon grease is relatively simple compared to the removal of petroleum jelly from insulators. So, this has to be followed. Resistive glazed insulator cleaning. So, resistive glaze or semiconducting glaze insulators can be treated the same as ordinary glaze like the porcelain insulators in concerning cleaning techniques, as cleaning will not damage the resistive glaze surface. However, it is unlikely that properly functioning resistive glaze insulators will require cleaning due to their superior contamination performance. So, resistive glazed insulators under pressure washing may overwhelm resistive glaze properties, so that resistive glaze insulators become as susceptible to accidental flashover as ordinary glaze insulators due to poor washing techniques. So, care has to be taken by the personnel or utilities while cleaning the resistive glazed insulators. So, room temperature vulcanized coating, we have heard about RTV coatings on the insulator surface for better performance. So, the cleaning of this RTV room temperature vulcanized coatings are also important, which begins to get contaminated and lose some of its water repellency. So, these RTV coatings are basically coated on the insulators to see that hydrophobicity is restored over a period of time. This could lose its properties and a proper cleaning mechanism has to be made. So, some room temperature vulcanized coatings can be done by using a high pressure washing, but there are RTV coatings where low pressure washings or flooding is also recommended. Once cleaning, the hydrophobicity is restored, that is a water repellent action on the insulator surface is restored. If recoating is necessary, the old coating can be removed by cleaning with an abrasive media such as a corn cob. So, this is simple compared to grease removal on the insulator, contaminated insulators which requires rags and a solvent. So, a messy and a time consuming operation which to be done in case of the greased insulators. So, detergents are not recommended to be used for the cleaning of the RTV coated insulators, as a new top layer can also be achieved by application of over existing coating without a removal of the existing layer. So, some cleaning may be recommended. However, lately dry cleaning methods for removing the spent RTV coatings are also available in the commercially, which are normally practiced. However, new RTV coatings may be more effective if the old coating is removed completely and then recoated. So, this decision has to be properly taken on the by the utilities. So, types of contaminants, this is an important point, how the contaminants or the pollutants get settled. So, what are the various types of contaminants which the utilities face or the insulators get contaminated. So, as the insulators are exposed in the field or outdoor, these are subjected to surface dirt deposits to some degree in all operating areas, which are commonly encountered contaminants have little effect on the insulator performance as long as the surface is dry. So, during surface conditions or dry conditions, no much threat of these contaminants. Once the fog, mist, light rain, this usually creates a conditions that produces a conducting film on the dirty insulator surface, which is without washing the impurities from the surface. So, this number of types of contaminants which have been identified as source of surface deposits on insulators will affect the insulator performance during the fog, mist or light rain conditions. So, these contaminants are generally distinguished primarily by the source of impurities, local, agricultural, industrial and geographical conditions which determine about the presence. So, the type of contaminants generally identified are the salt, the cement or lime, dust, bird excrement, chemicals, smog is an again emissions from the automobiles, cooling tower effluents, smoke, organic and ice, snow. These are various contaminants which are identified which could accumulate on the surface of the insulator over a period of time. So, we will discuss each and every contaminant, how these contaminants affect the surface of the insulators, how the cleaning has to be carried out, how the techniques to be washing has to be employed. We will further look into these type of contaminants and the cleaning mechanism. In case of wind and rain, these provide sufficient washing action to remove most of the deposits which have been mentioned, that is the contaminants on the surface. More than one of these contaminants may be deposited on a group of insulators at a particular location. So, the rain, high wind to some extent removes the contaminants which are spread on the insulator surface. The mix and rates of deposit of these contaminants determine the characteristics of the mixtures. So, various pollutants, contaminants which are identified are to be removed or cleaned at a regular intervals on the surface of the insulators. So, we will look into the importance of the cleaning and how it is to be done. So, here in case of salts, these transmission lines or substations which are near by the areas, it could be the sea coast or a body of salt water in that area adjacent to highways, particularly elevated roads where the salt is used to melt snow or ice. Substantial salt deposits may result from wind blowing and which gets sprayed on the insulator surface. So, in desert areas, near sea coast or near the highway junctions, so such deposits which are being carried out through the wind may make it necessary to clean these areas where long dry periods are followed by intervals of misty rain or fog. So, salt spray could lead to flashover and leakage current fires. So, here again depending upon the humidity conditions, the surface or because of the light rain, mist or fog, the surface becomes conductive and may lead to flashover or leakage currents. Initially where dry band wet band formation happens, small partial arcs or scintillations do happen, and further depending upon the surface conditions the flashover could happen. This condition is common on structures adjacent to high traffic roads, particularly along elevated roadways. Here insulator should be cleaned before the mist or fog occurs, not afterwards. So, salt which will quickly dissolve and wash off in a heavy rain or a stream of water. So, what happens in case the contaminant is a cement or a lime? These insulators which are located near the cement plants, construction sites, rock quarries may accumulate this dust from the cement or lime over a period, and materials may build up a thick crust which becomes firmly bonded to the insulator surface and which requires hand scrubbing as the cement or a lime settles on the surface and becomes hard. So, a chemical agent may be needed to remove the cement layers. So, usually dry method of cleaning also has proven to be quite effective. So, dust could be of various kinds and can be deposited on insulators which originate from a wide variety of sources. Some of the types of dust affecting insulator performance are earth dust, fertilizer, metallic dust, coal dust, feedlot dust and volcanic ash. This is not a complete list, but does cover many of the dust sources. So, there could be dust from various sources which accumulates on the insulator surface and could cause the contamination. Earth dust can arise from the fields when the agriculture activity like plowing of fields or because of the earth moving on construction projects, so on and so forth, where these methods various methods have to be employed for cleaning this type of dust due to the earth or due to the activity of the agriculture and the construction projects. So, water washing or a compressed air cleaning and wiping, both hot and hand cleaning are generally employed. The next is the fertilizer dust. This fertilizer dust is generally emitted from the fertilizer plants and from fertilizer application during the farming activities. So, fertilizer dust has been known to create a thick coating that has can be done using a high pressure washing which could not remove. So, in these cases hand scrubbing or dry washing is generally needed to clean the insulators. Sometimes liquid fertilizer of urea type is cleaned with water. Next is the metallic dust. This could originate from various mining and mineral handling process. So, metallic dust can be cleaned using compressed air and wiping, hot and hand cleaning methods. The next is the coal mining or coal handling operations. The dust gets settled on the surface of the insulators. Here again industrial could be due to the industrial burning of coal as a major source of coal dust or soot or fly ash resulting from the burning of coal from compounds that adhere firmly to insulator surface. These coal dust may be removed only with high pressure washing or compressed air with an abrasive substance. Feedlot, provender dust and earth dust stayed by animals in large feedlots can settle on nearby insulators in dry weather conditions. This dust is normally removed with water. Volcanic ash, again volcanic activity, this is concerning only the few countries where activity happens. So, here volcanic activity can emit large quantities of pollutants into the atmosphere in a very short period. So, thick layers of this volcanic ash could accumulate on the exposed insulators. This ash is not easily removed unless it is cleaned soon after it is deposited. Water washing or compressed air cleaning or wiping can be used. The next is the bird excretion or excrement. This is again insulators located at the vicinity of the roosts of birds, where large birds, particularly in countries like Australia and many places where birds take shelter on the transmission systems are of a serious concern and subject to contamination by the excrement. These deposits are usually washable and are often cleaned by heavy rain, but may present serious problems of system reliability. The methods such as water washing, compressed air cleaning and wiping can be used to clean these contaminants. Chemical here again the dust or because of the chemicals which could be sprayed on the insulator surface which are of serious concern. Atmospheric pollutants from a wide variety of industrial chemical process, aerial spraying of agriculture chemicals and firefighting chemicals are deposited on insulators. The characteristics of these chemical contaminants may vary widely. Some chemicals are highly soluble and can be washed easily, while other bond firmly and can be removed only by hand scrubbing. Next is the smog. Smog in urban areas, automobile emissions introduce a significant amount of particulate matter into the environment. In addition, diesel engine emissions from trains particularly affect areas adjacent to right of way. Normally industrial chemicals are present in areas with heavy smog problems. Various methods such as water washing, compressed air cleaning or wiping can be used to clean the smog. Cooling tower effluent. Cooling tower effluent is generally composed of water vapor and a small amount of dissolved solids. Under normal wind and temperature conditions, effluents should quickly disperse and not affect the insulator performance. However, under certain weather conditions, it is possible for effluent to create a localized fog. This fog may moisten dirty insulators, or if temperature is cold, ice, glazing or insulators may occur. So, any situation this can affect the performance of the insulator. So, the cooling tower effluent also causes a contamination similar to a fog or any other contaminants. So, smoke, this is again due to the industrial and agriculture burning activities or due to the wildfires. This can result in the contaminants spread on the surface with other compatible conditions such as moisture and humidity can cause the resulting contamination to accumulate on the insulation surface. So, smoke can generally be washed using water or dry ice or by wiping the surface of the insulators. In case of organic contamination generally consists of living or dead organisms or byproducts produced by them. So, common examples are the mold and algae. These are generally seen near the cement junction of the ceramic insulation or on the surface of the polymer insulators, which are in the high altitude and cold countries. The mold and the algae formation has been noticed. Here wiping and compressed air cleaning and washing can be effective in such places. The ice and snow conditions, where the insulator strings or the insulators are subjected to ice and snow. Here ice is an electrical insulator if its temperature is less than -2 degrees, but can cause electrical flashover if it starts to soften and melt at -1 degree centigrade. So, heavy ice or snow accumulation on insulator can sometimes be cleaned using preheated water that has a resistivity of more than 50,000 ohms centimeter as a conductivity less than 20 microsiemens per centimeter. Generally vertical pass to split the ice cover followed by injection of hot water stream between the ice and the insulator can be effective. The high water purity is required because the resistivity of water decreases by a factor of 2 as the temperature increases from 25 degrees to higher, that is up to 70 degrees. So, several of these contaminants which are discussed are generally noticed in the transmission or distribution or in the substation system, where these contaminants or pollutants accumulate over a period of time. So, proper cleaning mechanisms have to be done and necessary techniques have to be employed for the proper maintenance and also better efficiency, and without causing the contaminants flash over to the insulator in the transmission system or a distribution or a substation system. Now, we look into the frequency of cleaning. So, what is the frequency of cleaning required? So, this again is an important point where frequency of cleaning varies depending upon the degree of contamination. So, where exactly the insulators, which environment the insulators or which place the insulation is, so depends upon the contamination, the level, the weather conditions and the insulator design, the frequency of cleaning is essential or it is to be done. Here the frequent washing is required. It is sometimes economical to install either a piping systems on towers or a permanent fixed spray nozzle systems for washing. So, insulators are to be washed prior to the time of reaching critical contamination level. That is one of the important information. Should not be allowed for the contaminant to spread and accumulate for a larger period. So, this point can be estimated from the following. By taking the past experience on periods between flash overs or during a particular season or particular conditions of or pole fires, allowable equivalent salt deposit density has to be obtained from the de-energized testing of insulators or from the energized insulators. This gives the accumulation level, that is the equivalent salt deposit density. Degree of scintillations or a partial arcing during fog, wet or mist conditions, that is the damp weather conditions. Complaints about radio or a television interference, RIV or television interference which are caused during that period or during at that location. Proximity and exposure to the pollution source, how far the transmission system is available to the pollution source. Pollution source could be, as mentioned, an industry, or it could be a sea coast where the salt spread on the surface, or it could be the dust contamination, ice loading, or a cement or any of the sources. How far is the proximity, that is also an important information. The type of contaminant and its rate of buildup on the insulators. So, type of again various contaminants which we have discussed, and how the rate it is going to build up on the insulator surface is also an important aspect to be considered. Weather conditions. So, weather conditions, it should be noted that danger of flashover and pole fires is particularly great after a long dry period, either in winter or summer, which is followed by a light drizzle or fog conditions. Then the sensor insulators that indicate. So, several of this information have to be considered for the frequency of cleaning the insulation. Methods. The method used for insulator cleaning is dependent on the insulator material, construction, whether or not the line is energized, and the type of contaminant to be removed. Energized conditions, again here high pressure water jets are generally employed for washing. This utilizes a narrow stream of water with typical pressures ranging from 2750 kilopascals to 7000 kilopascals, that is 400 psi to 1000 psi at the nozzle. 4 types of nozzles are most important, which are often used with the high pressure water on the energized conditions, that is a live line maintenance, which is termed by the utilities or the utility personnel. So, they normally employ handheld jets of nozzles, remote control jets, fixed spray type of arrangements, and helicopter mounted nozzle jet arrangements. So, these are all the types of nozzles and the various pressures which are being adopted during the energized or conditions, that is the live line maintenance conditions. So, one of the fixed nozzle washing equipment and usage, here you see the table which clearly mentions about the type of nozzle and the spray method to be employed. Here you can see the number of nozzles, it could be multiple. Water pressure prescribed for the live line washing could be 350 kilopascals to 3000 kilopascals, that is 50 psi to 430 psi. Nozzle installations, it could be permanently installed on steel structures, as this washing is done at a regular frequency. Wash control, it is fixed. Washing coverage, the water envelopes and swamps insulator in one surge. Operations, this eliminates both climbing and special skill requirements for washing. Application, it is suitable in areas where washing is frequent to be done at least once a month and where tower or station structures are very high. So, this comes in handy where regular maintenance has to be carried out. So, other important features are piping to the nozzles is required for each insulator assembly. So, water usually controlled automatically. So, main disadvantage is again affected by wind. This method, in case of the wind conditions during the usage, could be disturbed for the regular washing. So, wind could play as a disadvantage for the washing conditions. So, methods for cleaning the transmission insulators, we did discuss about various type of arrangements and methods. So, high pressure nozzles, we discussed about the high pressure water nozzles such as 2750 to 7000 kilopascals, that is 400 psi to 1000 psi at the nozzle. These 4 types which mentioned earlier are of handheld or remote control or fixed or helicopter mounted. So, handheld jets, in general the line worker uses an aerial lift to raise the hose and the nozzle to the position to the line. Remote control, again here nozzles are mounted on a truck similar to here the truck arrangement. There is a boomer here and the nozzle jet, through the nozzle jet the spray is done to the insulators and the insulators are cleaned. This is how the remote control of the jet is generally done using a truck arrangement. The system generally permits positioning the wash system. So, it could properly plan and clean the insulators in either in tension or in suspension type of arrangements. Fixed spray nozzles, here this is effective mainly in preventing the sea salt contamination and flashover problems. Here wash parameters or equipments should be developed for each installation. Parameters like precipitation, water resistivity, wind, contamination severity, design and installation arrangement of the insulators to be washed. So, all these are of importance and several techniques are being followed for the water pressure and the nozzle sets. So, what is the minimum distance for the energized or the live line washing? Important information. to be safety precautions for the personnel to be taken care, and the minimum distance to be maintained while energized or a live line washing. So, this table gives you the line voltages, the minimal nozzle to conductor distance, minimum water resistivity, minimum nozzle pressure, and the maximum orifice diameter. So, the voltage levels are here. So, 13 kV and below, the minimum nozzle diameter is 1.82 meters. Minimum water resistivity to be employed is 1300 ohm centimeter. Minimum nozzle pressure is 2758 kilopascals, and maximum orifice diameter of the nozzle to be 4.7 millimeters. So, likewise, as the voltage level increases, the parameters of the nozzle to diameter distance, the minimum water resistivity remains same, the minimum nozzle pressure remains same, and the minimum orifice diameter changes to an extent with the depending upon the voltage level and the spray which is being done. So, this table is available in the methods for cleaning of insulators 957. Further reading is can be made, and the tables can be handy for the utility personnel who are regularly maintaining and using these methods, particularly during energized or live line conditions. The next is the helicopter mounted nozzle sets, which we have discussed. Here the system is generally controlled by the wash operator or a pilot in the helicopter. This helicopter hovers near the insulator string. You can see the insulator string here. The helicopter hovers very near to that at a particular distance, and the operation of the nozzles or the position of the nozzles is adjusted with the insulator string, so that proper cleaning and the nozzle is spray of the nozzles is directed to the insulator stream, is the directed stream to the insulator for the cleaning. Here again you have a fixed nozzle type of arrangement, where the pilot controls the direction of the water stream to the insulator movement by the helicopter. Then movable nozzle on a fixed wand. Here again the helicopter is moved to a general location, and movable nozzle controls the direction of the water stream. The other is the fixed nozzle in a movable wand. Here the helicopter gets to the required general position, and then washing is actually controlled by the other second person apart from the pilot. So, various arrangements are also being done by the helicopter mounted nozzle sets for cleaning the insulators or EHV and UHV transmission systems. This is also being employed in the country for the maintenance of the maintenance and cleaning of the insulators. These are again some of the cleaning methods which are again being used by the helicopter jets. You can see the insulator strings. These are the horizontal or the tension insulator strings which are being washed by the helicopter jets. This is one more arrangement where the helicopter, the second personnel from the helicopter, that is apart from the pilot, is using the water jet for cleaning the insulator. So, several arrangements are being done for the cleaning of insulators. It could be a fixed type or a pilot controlled, or the personnel, second personnel who is in the controls the spray and directs the spray to the insulator for proper cleaning. So, several of these methods are being used presently for the live line maintenance, some conditions, and also for the de-energized conditions in case of the cleaning. These are very important, as mentioned. Proper maintenance at the monsoon, before the monsoon conditions, is very necessary, else there could be the flashover or the trippings of the system which can cause a serious threat to the operation of the power system. So, maintenance cleaning aspects are very important. So, thank you. We stop here. We discuss about the de-energized conditions further.